Hello everyone, this is Brian Calc, and welcome to the final installment of the ARML Individual Challenge. Today we are going over problems 9 and 10 of the 2014 individual exam, and we are going to start right now. So, we begin with my favorite problem. We are looking for the greatest integer k less than or equal to 1000 in such that 1000 choose k is a multiple of 7. So 7 divides this. Now, one nice way to do it is to do 1000 choose 1000 minus k, and we want the smallest possible value, 1000 minus k. So, our goal is to first off just get a multiple of 7 up on the top. So, we know that 1001 is multiple of 7, 1001 I mean, so we subtract 7, and that gives us 994. So if we get 994 on the top, that means that we have 1000 times 994, which means we need 993 factorial here and 7 factorial here. So we have a 7 on the bottom and the top, and those cancel out. And we can see that every time we go down 7, this goes up 7. And so it's going to cancel out unless we can get a multiple of 49. So looking back at this is 7 times 143. So to get a multiple of 49, we need this to be a multiple of 7. So we have to subtract 3 7s, or 21, to get 980. Now we just need to make sure that the bottom does not include it. So we have 979 here. And since we subtracted 20, and so 1000 minus that is 21. 21 is not a multiple of 49. So, since we have 3 multiples of 7 here, and we have 3 multiples of 7 and 1 multiple of 49 up here, this is going to be divisible by 7. Which means 1000 choose 21 is divisible by 7, which means 1000 choose 979 is divisible by 7. 979 is our answer. Continuing on, we have problem number 10. And this one's going to be a harder one. So we have a function with the special property that g of x plus g of y is greater than x squared. And since the function is integer valued, we can rewrite this as greater than or equal to x squared plus 1. It doesn't really matter which one it is, so we're always going to assume it's the greater one. And we have g of x out of every function with this property, the sum of g of x from 1 to 20 is the smallest possible. And then we want the smallest possible value of g of 14. So, starting off, we have our g of 1 plus g of 2 plus g of 19 plus g of 20. And we can rearrange this to g of 20 plus g of 1 plus g of 19 plus g of 2. And that's going to go all the way down until we get to g of 11 plus g of 10. So this has to be greater than or equal to 20 squared plus 1 plus 19 squared plus 1 all the way down to 11 squared plus 1. So we can assume that, so if this is like a bare minimum, let's assume that we reach it somehow. Going off of this is let's look at what happens if g of 1 is less than g of 2. If we do that, then we have g of 19 is g of 2 plus g of 2 is 19 squared plus 1, which means g of 19 plus g of 1 is less than 19 squared plus 1, which is a contradiction. If we flip this around, g of 20 plus g of 1 is equal to 20 squared plus 2. And since g of 2 is less than g of 1, g of 20 plus g of 2 is less than this, also a contradiction, which means we get g of 1 is equal to g of 2. Then we try the same thing with g of 1, g of 3. If g of 1 is less than g of 3, then we get 18 squared, g of 18 plus g of 1 is less than 18 squared plus 1, So that works for g of 3, works for g of 4, g of 5, g of 6, all the way up to g of 10. So we have these values are all equal, and we're going to call this A. In case you haven't noticed, I'm using the official solution. I never actually solved this in practices, but I didn't want to let you guys down by skipping one of the problems, so we're just going to keep on going with this solution. So, given this, they are all equal, which means we have for n greater than 10, g of n is equal to n squared plus 1 minus a, where all these are equal. Where for n less equal 10, g of n is equal to a. So, since g of 11 plus g of 11 is greater than or equal to 11 squared plus 1, which is 122, we have g of 11 is greater than or equal to 61. Then, looking at this, let's see here. We add g of 11 and g of 14. Let's see here. We have g of 11 and g of 14. And these have to be greater than or equal to 196. No, wait, I'm doing it wrong. So we have g of 11 is greater than or equal to 61, so let's assume it's equal to 61. Then we have g of n is equal, then we have g of 11 is 122 minus a, so a is equal to 61 as well, which means that g of 14, by the way, since we set 11 as small as possible, a is as big as possible, which means 14 is going to be, g of 14 will be as small as possible. 197 minus 61 is equal to 136. And that is our final answer, and we finished with 2 minutes left on the clock. So, I hope you all enjoyed that. That concludes the 2014 ARML Individual Challenge. I will see you probably sometime in April, maybe later this, probably maybe sometime in March with my next video. But until then, be sure to like, comment, subscribe, and peace out.